Good morning ป๊าป๊า
Good morning, daughter. How are you today?
I'm fine thank you and you
I'm fine. What are you doing today?
I want to walk around the village
Yes, that's a nice idea. I remember near the village have a small park.
Let's go to the park ป๊าป๊า
Let's go.
ป๊าป๊า What is that
It is an electric post.
Why the functional of the electric pole
The function of electric post transmit the power to the people for use. Anything in your life, if we don't have the electric current, we can't use the electronic device.
Oh this is necessary for that ป๊า What is that
It is a snake.
ป๊า Hurry up Look at this The snake crawl on the electric post Look at this
Did it fall?
Wait What is false I don't know about it Can you explain it please
Fall or false current is any abnormal electric current. For example, a short circuit is a fall in which current bypass the normal load. An open circuit fall of which is a circuit is interrupted by some fail in three-phase system. A fault may involve one or more phase and ground, or may occur only between phase. In a ground fault or earth fault, current fall into the earth. The prospective short circuit current of a predictable fault can be calculated for most situations. In power system, protective device can detect fault condition or operate circuit breaker and other device to the limit the loss of service due to a fail. And this fault is like to ground fault. An unload balance three-phase synchronous generator with natural ground torque and impedance Z, each shown in fig, support a single line to ground fault, output on phase A, torque and impedance ZF. Since the generator is unload, the follow terminal condition excite at the fault point. VA equal to ZF IA. IB and IC equal to 0. Substituting IB and IC equal to 0 in previous equation, the symmetrical component of current is shown in the matrix. Solve the above equation. The value of the symmetrical component of fault current phase A are 0 sequence current phase A equal to positive current phase A equal to negative current phase A equal to 1/3 current phase A. The voltage of phase can be expressed in terms of symmetric component from equation as VA equal to VA0 plus VA1 plus VA2. Substituting in the equation the value of VA0, VA1 and VA2 from KVL equation into previous equation. VA can be written as this equation if VA equal to ZFIA equal to T ZFIA 0. Hence, previous equation can be expressed as this equation. First equation, it be easily interpreted that the T sequence network are connected in the series as shown in Fig. For solidly grounded generator, Zn equal to 0 and for voltage fault Zf equal to 0. Extending the above concept to the analysis of LG fault in a power system, the Thevenin equivalent circuit is obtained. Individual for the T sequence network. For the positive sequence network, V Thevenin, the open circuit P fault voltage at the fault point, and Z Thevenin, the positive sequence Thevenin equivalent impedance as seen from the fault point are determined. For negative and zero sequence network, only the Thevenin equivalent impedance Z Thevenin true and impedance zero Thevenin respectively are calculated. The T Thevenin equivalent network are then connected in series, and default current find from second equation. Do you understand?
Just listen. Can you show me an example, please?
Oh yeah, I will show you some example.
Two generators, generator 1 and generator 2 are connected respectively to transformer T1 and T2 to a high voltage bus which supply a transmission line. The line is open at the far end to which point F a fault occurs. The pre-fault voltage at point F is 515 kV. Apparatus rating and reactance are: generator 1 is 1000 MV, 20 kV. Impedance at source is 100%. Impedance subtraction position positive sequence equal to negative sequence equal to 10% and zero sequence is 5%. Generator 2 is 800 MV, 22 kV. Impedance at source is 120%. Impedance subtraction position positive sequence equal to negative sequence equal to 15% and zero sequence is 8%. T1 is 1000 MV, 500 star and 20 delta kilovolt. Impedance is 17.5%. T2 is 800 MV, 500 star and 22 star kilovolt. Impedance is 16%. At line impedance, positive sequence is 15% and zero sequence is 40% on a base of 1500 MV and 500 kV. The neutron of generator 1 is grounded to a reactance of 0.04 ohm. The neutron of generator 2 is not grounded. Neutron of all transformers are solidly grounded. Work on a base of 1000 MV and 500 kV. In the transmission line, neglect P-fault current and find subtraction current. A. In phase A at F for a line to ground fault. on line A and B in phase C of generator 2 for a line to ground fault on line A. Find the base current at line generator 1 and generator 2 is shown in the equation. The base current are calculated as line equal to 1155 amp. Generator 1 equal to 28.8 kilo amp and generator 2 equal to 26.2 kilo amp. Find the impedance in per unit system is shown in the equation. Generator 1 impedance subtraction equal to negative sequence equal to 0.10 and 0 sequence equal to 0.05. Generator 2 impedance subtraction equal to negative sequence equal to 0.15 multiply the 100 megavolt amp divided 800 equal to 0.1875. T1 impedance equal to 0.175. T2 impedance is 0.2. At line impedance positive sequence equal to negative sequence equal to 0.15 multiply 1000 divided 1500 equal megavolt amp equal to 0.1. 0 sequence equal to 0.267. Operating voltage equal to 1.03 per unit. This picture shows the positive sequence network and reduce to the next picture. This picture is zero sequence network. Single line to ground fault at F on line A. Positive sequence on phase A. Following at this equation equal to minus J 1.068 per unit. Subtraction current at phase A is equal to 3700. Single line to ground fault at F on line A. In generator 2, sequence current positive sequence equal to negative sequence and zero sequence equal to 0. Positive sequence current equal to minus J 0.443 per unit. Current at phase C equal to J 0.444 per unit. Subtraction current at phase C equal to 11.65 kilo amp.
Do you understand?
Yeah.
Now I think we should be go home because it's too late. Your mom waiting for you.
Let's go.